Okay, here is our second example. We're going to do, in this particular case, ammonia. NH3 is our example because it's going to show a couple things that I want you to see here. So remember, our first rule, count the number of valence electrons and then place the most electropositive atom or the single atom in the center. Draw a simple diagram, one bond to each outer atoms, and then subtract those. So we'll do that all kind of in one big step here. So thickness here, make this, there we go. So we have N and we have H. Now N is in group 5, so it has 5 valence electrons. H is in group 1, so it has 1 valence electron, but there are 3 of them. So there's going to be a 3 and a 5, a total of 8 valence electrons. Now we put nitrogen in the middle. We draw one bond to each. And because each bond represents 2 electrons, that's 2, 4, 6, we subtract out 6 valence electrons because we've used those up, leaving with this 2. Now, if you go back here and look, our next step here is to okay, so then we satisfy the octet rule for all outer atoms. Now, of course, this one involves hydrogen. Hydrogen is in the first row, and in the first row there are only a single 1s orbital, and that means there's only room for 2 electrons. So hydrogen isn't an octet, it forms a duet. And so in this case, we have our duet because of our 2 electrons from the bond. So the outer atoms are satisfied. Now the next step is any leftovers after we've satisfied that that's 2 valence electrons left. They go as a pair on the center atom. So we put it right there. They go as a pair. There we go. And then we subtract those off. And we have none left to work with. Now we go back, last step, check to make sure we have an octet on our center. 2, 4, 6, 8. It's good. We celebrate. That's a dot diagram for ammonia. Now let's just do one more. This time we'll do it with NH4+. So it's very similar to what we just did, but now we can just make sure you understand how to deal with this ion, which is what this one is, right? This has a positive ion, so we're still going to count. Now it isn't NH3, it's NH4+, right? So we've got N and we've got H, 5 electrons. We've got 1 valence electron, but there are now 4 of them. So we've got 5 plus our 4 for a total of 9 valence electrons. But we've got a 1 plus. So this is what we should have if we had NH4, but we don't. We have NH4 plus. That means there's 1 more proton, then electron. So we've removed an electron somehow. So we need to subtract that 1 valence electron to leave the 1 positive charge, and we have 8 valence electrons left to work with. So I'm going to go through this same procedure now. We're going to take N, goes at the center. We'll put H outside, H outside, H outside, H outside, 1 bond to each. And we put this now, what we do is we put a bracket around here and a plus charge up here to show that we're not dealing with NH4, but it's NH4+. We still have to subtract these electrons, 2, 4, 6, 8. We subtract those 8 valence electrons, leaving with 0. We now, no extras to put on the center, so we check. We've got 8 good. Celebrate because we have our octet on our center atom. Now we only have duets on the hydrogen because it's a group 1. I mean, it's actually not because it's group 1. It's in the first row, and it only requires a duet. But that's the dot diagram. So that completes those 2 examples. I want to do one more showing you some resonance structure, and then we'll be done with these examples.